So thanks so much for having me while the slides load up. Quick show of hands, who's heard of the Malaghan Institute? Oh, fantastic. Okay, for anybody who hasn't heard of us, we are an immunology lab based in Wellington. We're an independent research organization, and our focus is on immunotherapy, which means that we are looking for cures to a variety of diseases. And doesn't matter, I'll keep talking. So the focus of this, the focus on immunotherapy gives us a great opportunity to have breadth to work on various topics, on allergic and inflammatory disease, on infectious disease, and on cancer. And then the way we manage to be effective in this way is that the focus on immunotherapy and focus on curing diseases means that we can work on all stages of the process. So we can work from anything from fundamental research, why does a certain kind of cell behave in a certain kind of way under certain circumstances, all the way to running a clinical trial, which we are right now on CAR T-cell research, and all the way to running a spin-off technology company on delivering all of that to healthcare, to the healthcare system. So, hi, I'm Hercules. I'm a data scientist. My background, I'm the head of the data science core facility at the Malaghan, which is new, and this is what I'm here to talk to you about. My background, first 10 years of my professional life was as a research scientist, but not in biology. So if I say something dumb about biology, please excuse my ignorance. I'm learning a lot at the moment. It's a lot of fun. So I was an astrophysicist for the first 10 years of my working life. I worked in various labs and universities, very data-intensive science, astrophysics, obviously. And then 10 years ago, thereabouts, I took a sidestep into data science. I worked in big tech companies for a while. And then I've been working in renewable energy and things like that for quite a long time. And I was in the middle of trying to stand up an AI startup in geothermal energy here in Aotearoa when this job ad came up, and thought, well, I have to apply to that, even though I'm not a biologist. So a year later, here I am to tell you about all this stuff. It's really, really, really exciting intersection of various sciences and technologies. So if you haven't heard the term core facility, I hadn't either. I asked during the interview, which wasn't embarrassing at all. And it turns out it's a group of technical experts who take care of a specific experimental platform. So we have a bioimaging core facility, people who take care of microscopes, advanced microscopy, genomics core, we have a flow cytometry core, and now we have a data science core. And the idea is that you have a role in advocating for platforms, purchasing the platforms, operating the platforms, and training the research on how to use the platforms when they get there. Data science is no different. This is completely rhetorical in this audience. The very, very quick answer is because we didn't have a coordinated approach to e-research. This is a really good moniker for what we're doing. The first thing we did, so this is the story of setting this up from scratch, right? This is December of 23. I arrive at the Malaghan. We have to think about what is it that we need to do here. I say day 1 mission, this is more like day 28 mission. A month in, we've got an idea of what we want to be doing. And it is to provide support to our researchers and our collaborators by developing data pipelines and analysis techniques and statistical models and applications to support their analysis. Integration is the biggest word in this whole thing, in this whole talk. If there's one thing that you need to take away, and the one success that's really obvious in this program, is to meet the user where they are. So people have very complicated data sets that all of these machines spit out. And any given experiment might use all of these platforms that I mentioned before. You'll go through the flow cytometer, sort some cells, bring them to genomics to the genomics core for sequencing. Or you might go to microscopy, or you might do something completely new that we haven't seen before. So meeting people where they are is the crucial part. We can't just tell people, oh yeah, go learn how to code and we'll talk in 6 months. That's obviously not the way this is going to work. And of course, the last part that I mentioned there is about knowing, because we're a charitable trust, we have to be very, very careful and conscientious about how we use our funding. So by design, forever, this team is going to be very, very lean, like every other core facility at the Malaghan is. So we have to know how many people we need to fulfill our mission. That was the main goal for the first year. Once we decided what we're supposed to be doing, to be a service organization inside a very complex research institute, we set about figuring out how do we get the people who have all the skills that we're going to need. And we knew we're going to be doing a lot of data analysis in QC, we're going to be running pipelines, there's going to be a lot of coding and platforms involved in that, and there's going to be a lot of user training involved in that at various levels. So we've got 3 people, 4 including myself, on the team who are working on data science, biology, data analysis, and DevOps. And DevOps is the really interesting one. It's the first role we hired in this team externally, and it's been an amazing success, and I've got a couple of more things to tell you about that. Day-to-day operations for a data science core, I can bundle things into 3 categories. There's more that we do, and the training part I haven't included in this, which is a huge activity, but in terms of the technical things that we do, we obviously participate in research projects. Somebody will come to us and say, I've got this data set, I would like to run this kind of analysis on my data set. At some level, this is basically us going, okay, we're going to learn about your data set, we're going to learn about the technique, if we don't already know about this, and we're going to figure out how we're going to do it. We're going to sit together, and whatever level of training you would like to have, we're going to provide that. That's a completely reactive model, which is the starting point where we were a year ago. The researcher know what they want, and they're not able to accomplish that goal on their own, so we help them accomplish the goal in whatever specification it comes to us. The first thing we need to do for a lot of that is big computers. You can't run that on your laptop most of the time. If you're running even 10,000 cells on a single cell experiment, you're not going to have enough RAM on your laptop to run this thing, so it's going to go to a server, to a dedicated facility. So we need to help you run this. We need to help researchers figure this out, or we need to run it for them in some cases. So by lowering the barrier to entry to our modest HPC, which is growing, we make it a lot more possible for people to self-serve. This is still a high level of self-service, though. So the third activity, and I should add there for the HPC, is that we work with IT very, very closely. We have a fantastic collaboration, which has been really a real part of the success, which is we don't have to take care of the racks. Bare metal is for IT to worry about because we don't know what we're doing when it comes to that. But also IT don't want to deal with the sysadmin of the research software side. That's just too much fuss. So we've found a really nice collaboration of having a nice delineation of responsibility there. That's been great. So HPC, teach somebody how to use the HPC is still a high barrier for most people. So the third activity that we're doing, and it is ranked third in terms of how much we have done so far, but it's becoming a bigger activity, and it's the goal for us to have it as a main activity, is to build tools. Researcher comes to us, says, I have this kind of data set, I want to run this kind of analysis. The ideal scenario for me is, yeah, we have a tool for that. Go to this IP address, go to this link on the server, we have a little GUI, have a little go, we can sit down with you and train you on how to use the thing if it's not intuitive. That's the aspiration, and we're already on the way with that with genomics, for example. I call out genomics there because this is the one area where the moment the data out of the machine, you have to start coding. There are tools out there, some off the shelf, but there isn't one tool that I know that people buy and are super satisfied with that does all the kind of different things you might want to do with genomics. And because we're an institute of 130 people, we're not gonna, we can't really have $5,000 a seat on 10 different apps. That's not really going to work, so we have to coordinate these things. So all of this is, in one form or another, since we don't take care of the racks, is digital technology. It's software, it's apps, it's things like that. So there's one huge advantage that we have that lets us move really, really, really fast, which is that we are a relatively small organization and we're independent, so we kind of decide how much red tape we need. And it's okay to have a case-by-case decision because we don't have heaps and heaps of people, and we don't have to also make a rule that applies to astrophysics and molecular biology that have very different requirements. You know, galaxies don't have data rights. It's very difficult to have these rules that at a university level. So that's one of the reasons that's one of the drivers for our velocity, essentially. One of the, so build versus buy is always there, it's always on my mind. Anytime we have a breakthrough with one of our pipelines, with one of our techniques, there's always the next step, let's build this thing so we can serve it that way. And that's always a crux, that's always a point of decision. That is, well, how much is it going to cost to build this thing ourselves, to maintain it, what is the staff time and all that? Again, because we're a charitable trust, we have to be very, very conscientious with this. Sometimes it's a lot cheaper to just buy a license. When we do make these decisions, a huge deciding factor is actually user base for all of these applications that we use. And I have a more specific example of that, but essentially something you can troubleshoot really, really fast is preferable to something that is a niche piece of equipment, digital equipment, that is difficult to troubleshoot. And then generalizing is just the principle that you just use the right tool for the job, be it a language, a platform, or a protocol. And that's kind of it. So I have, it was so hard to pick projects because this team is so productive. They do so much work in so many ways. But I had to pick 3 just to stay on time. And the first one is the most boring one, but the most important one, which is get people to use Jira. Ooh, at a research institute. Interesting. So obviously I've spent a lot of time in tech. So I actually, for full disclosure, used to work at Atlassian. I don't own any stock anymore, so I don't benefit from convincing the lab to get Jira and Confluence. So it's been a total revolution in the way we do things. First of all, with all of the PIs having access to these tools, everybody can see what we're working on. And this isn't just data science, this is all the core facilities. Everybody can see what we're working on, and that creates the visibility of, you know, hey, why isn't this thing done yet? Nobody has to get into that mode. Nobody has to doubt that they're not important enough to us. All of our users are really important to us, but there's a lot of stuff on the board. For us as a team to prioritize, since we have such a clear mission, both as a data science core and as an institute, help researchers find cures to diseases, very easy to prioritize when it's all written down and visual and it's not all in your head. And then, of course, writing everything down is one attitude that I've kind of insist on and get some people's nerves sometimes, I have to admit, which is essentially act like you're a remote team. We're all co-located, but write everything down. We know we have a decision log. We know why we made certain decisions at certain points. We can refer back to that and revisit later. Really helps with operations. I mean, how have we gone so far without showing the little blue whale? How is it possible in an HPC conference that we haven't shown this logo so far? So this is an example of user bases and all these principles I was talking about before. When I arrived, one of the things that, I was taking stock, I was asking all the researchers and bioinformaticians and everybody, what are some big blockers? I understand that the HPC isn't quite working for you, the server isn't quite working. Give me one of your problems. And the most common grumble was about singularity, which is a perfectly fine protocol. But what I heard was that, well, it works most of the time. But when it doesn't, it can take me weeks to troubleshoot. So then I went asking a few questions. Why do we use singularity? It was a specific security requirement. Okay, let's figure out how to fulfill that security requirement with Docker. So I went and talked to IT. We had a program there to figure out what's going on. As soon as we were satisfied that the way we wanted to set up Docker was secure and was just the same, then we just roll back essentially, went to Docker. People can use ChatGPT in 4 seconds to troubleshoot any problem that they ever have with their containerization. Lower barrier to entry for usage of the modest HPC. And then Docker begat, Harbor, and then this, and then that, and all these open source tools that we can just use. And now we have pipelines, we have DevOps. It just works because that basic little first point was the sticking point, and now it's not. The last one I'll tell you about is definitely the coolest one, and I'm going to try to stay on topic because this is such an amazing technology. I mentioned genomics. This is one of the platforms and teams that we work with most closely because, again, once the data come out of the sequencer, you have to code. So we have a really pretty cutting-edge technology, which is Oxford Nanopore kit. A nanopore is a biological barrier. You imagine a chip. It's called a flow cell. You put your cells, you fixated whatever cells, I'm not a biologist again, sorry, on the flow cell, and then the RNA is attracted to the little pore. As it goes through the pore, there's an electrical current that's applied across the chip, and that modulation in current is read by a neural network, quite a hefty neural network, which then reads the base. It's called base calling. So is it an A, T, G, or C? Technically U, I know that much about RNA. That's obviously, you've got niche genomics and genetics equipment and niche computing, because that neural net is quite cantankerous. So this is one of the things we took over. This used to be the responsibility of genomics. It was very hard for the genomics core to be great at lab stuff and computing stuff. We went in, reset the computer essentially to a state that we knew we could control, and then we can provide a predictable service. So that's been a really fantastic success story for collaboration between cores. And it also now, because you have the computer nerds in the room, well, we can think about what more we can do with this technology. Oh, great, we can upgrade the GPU and we get this. We get another GPU on this machine and we get more expense running at once. So all of that collaboration happens when you just open the door. So I see I'm getting kind of reined back. So that's my last experiment I want to talk about, and thank you so much for your attention.
Thanks, Hercules. Time for a couple of questions. Oh, no questions. I will comment that your galaxies may well have data sovereignty issues, and we have the issue that we have to be able to connect with them and consult, or make the contact, right? So we do have something to address there that an astrophysicist might be good for, right?
Let's make contact, and then it's a great obstacle to have.
Okay. Any last chance, comments, questions? Okay. Thank you, Hercules.
Thanks so much.